Hey, today we're going to talk about a topic that is very common throughout the universe, and that topic is entropy. And what entropy means is it's just a way of basically saying disorder or randomness. So if you were to look at my room, for example, as much as I try, by the end of the day, my room just looks like a mess. And those of you that have been inside my classroom, you can kind of tell it gets a little bit messy as the day progresses. So you could also, not for me, but you could talk about your hair. You comb your hair, make it all nice in the morning. Not me. But your hair would look a lot messier as the day progresses. You get your braids done, you get weave done, whatever you get done to your hair, over time it's going to get more and more random or disordered. And that's what entropy is. And entropy has a lot to do with particles wanting to just basically be dispersed. And like, they don't really want to have order to them. And we also see some of these same concepts being applied to energy. We have very pure forms of energy and we have very impure forms of energy. And when energy changes from one form of energy to another, it's actually losing some of that energy as heat. So we've been talking about heat, and heat is one of the least pure forms of energy. Let's say, for example, this book. This book is held high. This is the energy of position, or the potential energy. When I drop this book, the potential energy changes to kinetic energy. Not all of that energy. A very slight amount is lost as heat. When it hits the ground, that kinetic energy changes back to potential energy, losing some of that kinetic energy as heat. So even though you might not feel it, when it lands on the ground, there is a slight amount of heat that is created. So again, what you need to remember is as energy is converted from one form to another, some of that energy is lost as heat or thermal energy. That's basically it. A couple of things. First of all, regarding heat, heat will travel from areas of higher temperature to areas of lower temperature. Or in other words, from areas with higher thermal energy to areas with lower thermal energy. So if you had a nice ice cold glass of soda that was hovering at 0 degrees Celsius, and you were holding it in your hand that is at 37 degrees Celsius, what's happening is the soda is not making your hand cold. What's actually happening is the heat from your hand is being transferred into the glass, into the soda. And it's causing the temperature or average kinetic energy of the soda to increase. The average kinetic energy or the temperature of your hand is starting to decrease. Remember, heat goes from areas of higher temperature to areas of lower temperature. Okay, regarding entropy, we have three phases of matter. We have solid, we have liquid, and we have gas. Remember, entropy is randomness or disorder. So as you increase in temperature, you're actually increasing in entropy. As you change phase from solid to gas, you're increasing entropy. Entropy increases as you increase the temperature. And one last thing that they're going to ask you on the Regents, if you have an aqueous solution has more entropy than a solid. They're never going to ask you to compare an aqueous solution with a liquid or an aqueous solution with a gas. But compared to a solid, an aqueous solution has more entropy. Okay, to summarize, entropy, randomness, disorder. Heat is a form of energy that is the most degraded form of energy. Heat travels from high temperature to low temperature, and entropy increases when the temperature increases. You're going to look right over here. Practice. Peace.